Hello everyone and welcome. Today we are diving into the world of context-free grammars, a fundamental concept in the theory of computation. This presentation will cover the definition of context-free grammars, also known as CFGs, along with derivations and parse trees. Let's get started. So, what exactly is a context-free grammar? A context-free grammar, often abbreviated as CFG, is a formal system used to describe the syntax of programming languages and natural languages. It does this through a set of production rules. Context-free grammars generate what we call context-free languages, and they are more powerful than regular expressions, which are used for simpler pattern matching. A context-free grammar can be formally defined as a four-tuple. That is, it is defined by four components, which are represented by the capital letters V, T, P, and S. So we can say that G equals the tuple containing V, T, P, and S. Now let's break down these components. The first component, V, stands for variables, also known as non-terminal symbols. These are symbols that can be replaced by other symbols according to the production rules of the grammar. The second component, T, represents terminals. Terminal symbols cannot be replaced further. They are the final building blocks of the strings that the grammar can generate. Moving on, P stands for productions. These are the rewriting rules that define how variables can be transformed into terminals or other variables. Productions are typically written in the form A goes to alpha, where A is a variable and alpha is a sequence of terminals and/or variables. Finally, S denotes the start symbol. This is the initial variable from which all derivations begin. It is the starting point for generating strings in the language defined by the grammar. Let's look at a simple example to illustrate these concepts. Consider a grammar G with the following productions: S goes to ASB, and S goes to AB. This grammar generates a language, L of G, which consists of all strings of the form A to the power of n, B to the power of n, where n is greater than or equal to 1. In other words, it generates strings like AB, AABB, AAABBB, and so on, where the number of A's is equal to the number of B's. Next, it is time to understand derivations in context-free grammars. Derivations are a sequence of steps that transform the start symbol into a string of terminals, using the production rules. There are two main types of derivations: leftmost derivation and rightmost derivation. In a leftmost derivation, we always replace the leftmost variable in each derivation step. For example, starting with S, we might have the following steps: S goes to ASB, then ASB goes to AASBB, and finally AASBB goes to AAABBB. Conversely, in a rightmost derivation, we always replace the rightmost variable in each derivation step. Using the same grammar, the steps would be S goes to ASB, then ASB goes to AABB, and finally AASBB goes to AAABBB. Note that while the order of applying the rules is different, the final string generated is the same. Now let's discuss parse trees. Parse trees are a tree representation that shows the syntactic structure of a string, derived from a context-free grammar. In a parse tree, the root is the start symbol, the leaves are the terminals, and the internal nodes represent the variables. Consider constructing a parse tree for the string AABBB, using our example grammar. The root of the tree would be S. From S, we have branches to S and B. The S node then expands to a S and B again, and so on, until we reach the terminals and B at the leaves of the tree. This tree visually represents how the string AABBB is derived from the grammar. Finally, let's consider the relationship between derivations and parse trees. Every derivation corresponds to a unique parse tree, and vice versa. Parse trees provide a visual representation of the syntactic structure described by derivations, making it easier to understand how a string is generated by a context-free grammar. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.